I will take some special problems for NEET JEE exam because for NEET exam the long calculations are not to be required, so you have to learn the formula directly. Now first I will take that what is the force acting on a rod rotating in the horizontal plane, and about the axis which passes through its one end and perpendicular to the length of the rod. So now I take first number 1. The force on a rod of mass m and length L rotating in horizontal plane about an axis passing through one of its ends and perpendicular to length. This is now we have found. Let this is now rod. This is the rod. And this is the axis of rotation. It is rotating with the angular velocity omega. Its length is L. Let this is now L length. This is suppose point A and this is now point B. So when the rod is rotating in the horizontal plane, a centripetal force acts on the rod. The centripetal force acts on the rotating rod AB. This is a rotating rod. So now let us consider an element. This is now an element. This is now suppose length is dx, and this is now at distance x from the axis of rotation. So consider an element of length dx at distance x from axis of rotation. So now let lambda equal to m upon L. This is the mass per unit length. So now mass of the element, mass of element, this now dm is equal to lambda into dx. So this dm is equal to m upon L into dx. Now the force on the element. The force on the element. Now this dF is equal to dm. This is now, and the distance is x, and this is now omega square. We simply use the formula mr omega square. Using dF is equal to mr omega square. So in place of this m, we will have this dm. R, this is now x, this is now your omega square. So now you put the value of this dm, so that will be your m omega square upon L into x dx. This is only element L, element dx. So now force on whole of the rod will be how much? Therefore, the force on the complete rod Now this F is equal to integration. This is now your 0 to L, and this is now your m omega square upon L into x dx. This is so much. And this F is equal to, now this is m omega square upon L into this is now your x square upon 2 limits 0 to L, and this will give you 1 by 2 m omega square L. This is equal to now force. This is so much. Now this we have taken when the axis of rotation passes through one of the end of the rod. If suppose this axis of rotation passes through the middle point of the rod, then how much force will act on it? So now second. Force on the rod rotating about an axis passing through center of rod and perpendicular to its length. Now we are having this. This is now suppose the rod. This is now rod, and this is now axis of rotation. This is now rotating like this. So this is now center. It means that this is now a distance that will be now this L by 2, and this is also L by 2. This is a rod AB. This is rotating. So this is like this one. This is now rod, and this is rotating like this one. About this axis, this is now rotating in this way. So then you have to find that how much force will act on it. So we will find it in the similar way as it has been given earlier. So let us find this is suppose element of thickness x, and and this is a distance x from the axis of rotation. So this is our rod. So let lambda equal to m upon n. So mass of element, dm equal to lambda into dx. So this dm is equal to lambda is equal to m upon l, and this is your dx. So much. So now force on the element. Force on the element. This is now your df. This is equal to dm into x into omega square. So this is now m omega square upon L into x dx. Now you see that this rod is pivoted at the center point. It means that this x will also be on this side. So this will vary from Ly2 to Ly2. So if we take this to be now minus, then this will be now plus. So minus Ly2 to plus Ly2. So now then we have the force on the rod. Force on the rod. This F is equal to integration minus Ly2 to plus Ly2. This will be our limits, and this is now your m omega square upon L into this is your x dx. So this we will do it like this: 2m omega square upon L into integration 0 to L by 2 x dx. This is the law of integration. Then when the limits are equal and opposite, then we can eliminate the lower limit by applying 2, by multiplying 2. M omega square upon L, and this is now your x square upon 2. This is now so much 0 to L by 2. So now this is now 2m omega square, and this is now your L, and this will be your 1 by 2 into L by 2 whole square. So this will give you how much? Now this 2 and 2 will cancel. So this is now your m omega square L upon 4. This is now force F. This is so much. So this is the force when the rod is rotating about an axis which passes through its center and perpendicular to the length. So you can see that initially it was this m omega square L upon 2. So now when we pivot this at the center, then this F will be half of the initial value. So this is the force. And now let us find Now I will tell you a general formula about the force or the tension in the rod when this rotates in the horizontal plane, that you can find in what way. So now number 3. Tension or the force on a force at distance x from axis of rotation of a rod rotating in horizontal plane. Rotating in horizontal plane. So ये that I am taking to this one. This is now axis of rotation. This is now rod. This is now rod A B, and this is now being rotated like this one. This is now angular velocity omega. So let us consider this again, the element this dx, and let this distance is x. This is now x. So we will have a similar now let lambda equal to m upon n. M upon n. So mass of element dm, this is equal to lambda dx, or this is equal to m upon n into dx. So now the force on element, this now your df is equal to dm into x into omega square. So this is m omega square upon L into x dx. This is equal to x. We have to find it here. So now force from x to L, that we will find. Force from x equal to x to x equal to L. X equal to L. Now this F is equal to integration x to L. This will give you a general formula that you can use for at any distance of the rod. So this is your m omega square upon L into x dx. So this is m omega square upon L into x square upon 2. This is now your x to L. So now this will be how much? F is equal to m omega square upon L into this will be your L square minus x square upon 2. So this F is equal to m omega square upon 2L into L square minus x square. This is not general formula. This is general formula. And x we can have any value. That is, this x may be this L by 4, L by 2, 3L by 4, and then x equal to L. So this will be how much? So we take the different situations. So as you see from here that when this x is small, then this force will be maximum. So now we take the first case for x equal to 0. This F will be equal to how much? M omega square L upon, this is now your 2. This is now maximum force. It is maximum. Maximum force. It means that the rod which is in contact with the axis of rotation, there the force will be maximum. For x equal to L by 4, this F is equal to, now this m omega square upon 2L into, this is now your L square minus L by 4. This is now whole square. So much. So this is now L by 16, so 15 upon 16. 16, this is now 32. So F is equal to 15 upon 32 and omega square L. This is not so much. And you can see that this force is less than this one. Less than this one. If we write down this in terms of this force, then definitely it will come out to be less. And third, for x equal to L by 2. L by 2 means at the midpoint. Then this F equal to m omega square upon 2L into, this is now your L square minus L upon 2 whole square. This is not so much. In place of this x, you will write down this L by 2. Then this is now L by, this is now 1 by 4. So this is now 3 by 4. So 4, this is now 4, this is now to 8. So this is F equal to 3 upon 8 and omega square L. This is not so much. So we are looking that as the distance is being increased, the force is decreasing. And now if we take third, fourth, now this x equal to 3L upon 4. So this F equal to will be how much? M omega square upon 2L into, this is now L square minus 3L upon 4. This is now whole square. So much. So this will be, if we calculate this is your 16 minus 9, 7. So this is now your 16 and 2, 16. 16 and 2, 32. 32. So this is now your 7 upon 32 m omega square L. This is so much. And now last we will take fifth for x equal to L. The F is equal to m omega square upon 2L into L square minus L. This is now your whole square. So this is now your L square. So this will cancel. So this F is equal to 0. This is the minimum force. So what do you see from here? That as the distance increases from the axis of rotation, that the force or the tension in the rod goes on decreasing. It becomes 0 at the last end. So this is x equal to L at the point B that I have shown you in the figure. So at point A the force is maximum, and at point B, the last point, that there is the force is 0, the minimum. So as we go away from the axis of rotation, this force decreases. So this is, I have told you, a general formula like this one. This is a general formula, and here you put the value of x, any value of the x that is given in the question. You find the force or the tension in the rod rotating in the horizontal plane about an axis which passes through its one off end and perpendicular to the length of the rod. Now I will tell you a problem that when the rod is suspended vertically, then how much will be the increase in length because of its own weight. So this will be, I think, this was the number 1, and note to that. This is number 1, number 2. Number 1, number 2, and number 3 and 4. So now I take the number 5. One, two, three, four. Number 4. Increase in length of wire suspended vertically due to its own weight, due to its own weight. Let's suppose this is a wire, this is a wire. Now its length is L, this length is L. Now this wire gets extended because of its own weight. So now this wire becomes like this. Now this is no extension, this is no extension, L. This is no extension. So let us find that what will be this extension in this. So This is now given a iron, and let we consider that this is an element of thickness, length x dx, and this is at distance x from the point of suspension. This is not so much. Let W equal to weight of wire. This is now, suppose we take this AB of wire AB. So this weight will be divided along this length. So let lambda equal to W upon L. This is now weight per unit length of this wire. Weight of element. This is now element. Suppose this is now your PQ, element PQ. This is now your DW. DW equal to lambda into dx. So this is now W upon L into dx. When we have taken this to be now x, then this will be your L minus x. So now we have not to take the elements of this one. The weight on this rod will be because of this part, L minus x, because so much part is being suspended from this element dx. Weight of length L minus x, this is now your dw is equal to lambda into L minus x. So this is equal to now your W upon L into L minus x. This is now equal to dw. So now Young modulus Young modulus Y is equal to the force. The force is how much? Delta W, that we will use here, dW upon the area of cross section is A. This is divided by the change in length. Let we are having this length is so much. This is now your dl. So this is now your dl upon dx. dl upon dx. Here we have taken the element dx. This is now change in length dl. So this strain will be dl upon dx. Or this y is equal to dw upon a into this is now your dl into dx. So how much this now dl? This is now dw that you will put here. This is now your W upon L into L minus x, and this is now A, and this is now your dx. This so much is dx. Okay. Now this we have to remember that the weight here, this will be due to this length. If suppose this we would have given to be L by 2, then this distance, this will be now L, this will be L by 2. So this we will write down here this L by 2. तो हम करते क्या है कि इसमें जितना पार्ट का इसमें पूछा गया है उससे नीचे का जो पार्ट होता है उसका हम वेट कंसीडर करते हैं. सो नाउ टोटल इलॉन्गेशन कितना हो जाएगा? टोटल इंक्रीज, टोटल increase in length or elongation. Elongation. This L is equal to, this we have to find to this L is so much. Now this is integration. Now this X, this is now 0 to L, and this now we will take is W upon L A into L minus X dx. So this is equal to W upon L A into, ये हो जाएगा आपका L minus x स्क्वायर अपॉन 2 0 to L. टोटल लेंथ निकालनी है. यहाँ पर L का मान 0 है, यहाँ पर L का मान कैपिटल L के बराबर है, तो 0 to L. ये कितना हो जाएगा टोटल? दिस विल बी W upon L A, and if we put the limit, then this will be your L square minus L square upon 2. This is not so much. So you can see that this L equal to W L upon this one L will cancel, so this is now 2A. This is not so much. A is the area of cross section, where A equal to area of cross section of Y. So this is not so much, that this will be so much the increase in length, and this term by is also left here. This is not by here. This is not by. This is not so much. So you can see that the increase in length will depend upon this W, L, A, and this Y. So suppose we have to find it for a general one, then we can take it to 0 to x. Now for different lengths you can have the different formula. This x equal to, suppose this x equal to L, x equal to 2L, x equal to 3L, like that. Then we can have this formula. So a general formula. तो जनरल फॉर्मूला हम इसको कैसे कर देंगे? नाउ दिस L इज इक्वल टू W अपॉन L A y इंटू LX minus x square upon 2. Now you put any value. You put any value. This x is given to be now suppose L by 2, and this is given to be now suppose L by 4. Then you you can use the value of x. So value of x can be taken any the length of the wire. So here this we have taken the L, right? If suppose L is given to be now L by 2, then we can use to this to find the increase in length. So from that this L by 2 will also come in. So I think this will not be better. This will not. So now I will tell you now a numerical question. That is now your number 5. Now numerical question is a uniform rod AB of length 12, AB of length 12, 12 and mass M, is rotating in horizontal plane about a vertical axis. Through A axis passing through A with the angular velocity omega with angular velocity omega when midpoint of the rod strikes a fixed nail. Fixed nail and is brought immediately and is brought immediately to rest. If the impulse exerted by the nail, if the impulse exerted by the nail is, this is your Find the value of x. This is the question. A uniform rod AB of length 12 and mass m is rotating in the horizontal plane about a vertical axis passing through A. This means that at one end with the angular velocity omega, when the midpoint of the rod strikes a fixed nail and is brought immediately to the rest, if the impulse exerted by the nail is so much, find the value of x. This is the x we have to find. What is given here? This is now a rod this is now the rod AB. Its length is 12. This is now nail. Here, this is now nail. And the length of the rod is 12. This is rotating with the angular velocity omega. Its length is 12. This AB is equal to 12. So definitely now this length will be now L, because this is at the midpoint. This nail is at the midpoint of this. So कैसे this is now like this one. This is now rotating in this way. And here is a nail. So this is strikes with the nail. And as it strikes the nail, it comes at the rest. Now I have told you about the angular impulse. So angular impulse equal to change in angular momentum. Change in angular momentum. The impulse J. This is equal to change in momentum is how much initially at the last. This comes at the rest. So now 0 minus I into omega. Initially the angular momentum is I omega, and after striking to the nail, this comes as rest. So this final angular momentum will be 0. So 0 minus I omega. And this is equal to J. We know this. This is equal to angular impulse. If the impulse, now you see the impulse. So this impulse that is given here, this is now linear impulse. So now linear momentum. If the impulse on the nail is so much, and J equal to angular impulse, this change in momentum that we know it to be angular impulse J. This will be now your torque. This is equal to minus I omega. Now change in angular momentum, that will give you the this angular impulse. Angular impulse denoted by J. तो ये J are perpendicular. J the linear impulse, linear momentum. J, and this J equal to I, M into B. Angular impulse. This is the angular momentum, and this angular momentum is equal to so much. This we know. P is the linear momentum. P is equal to minus I omega upon R perpendicular, where impulse नहीं है, P is not equal to the impulse. If the impulse exerted by the nail is so much, find the value of x. This I omega R perpendicular. This is not torque. This angular momentum is equal to the P. So I think in this impulse, this must be the linear momentum. This must be linear moment, because this impulse will be equal to so much J. This is equal to so much I omega. Where P equal to linear momentum. This is a perpendicular distance. So this perpendicular distance, that is equal to L from here. Now moment of inertia. Now this P, that is P is given to you this 4 ml omega upon x. This is not the impulse. 4 ml omega upon x is equal to, this is now your ml square upon 3, and this is now your ml square. तो इसमें से ये एल स्क्वायर कैसे कैंसिल होगा? This is now your omega upon this is now your L. So here I is equal to ml square upon 3, and this R perpendicular, this is equal to L. So this m and m will cancel, इस L से ये कैंसिल हो जाएगा, ओमेगा से ओमेगा कैंसिल हो जाएगा, और इस L से ये L कैंसिल हो जाएगा. This L will cancel by this one. So now x equal to 4 by 3. M, and this is equal to 2L, 2x, so much. This is now your M. Now this 4L square upon 3 into omega upon L. This is not so much. 4 will cancel by this 4m, and this omega will cancel. So, or x equal to 3. This is the answer. But here I think this must be in place of impulse. This must be the linear momentum. लीनियर मोमेंटम, तो इम्पल्स एग्जर्ट करेंगे तो फिर जे का मान यहीं पर आ जाएगा पूरा, फिर इसमें ये कैसे निकालेंगे. So in place of this impulse, this must be, I think, linear momentum. Change in linear momentum. In place of this impulse, this must be change in linear momentum. Change in linear momentum. This only then we can find, because if this is given the impulse, then the J is also that is already equal to this. We are given this impulse J, so in place of J we have to write down to this one. But the answer is given to be 3, so we have to find the this linear momentum. Linear momentum. This is what. So this is about this example that is very important, and I have told you so many examples today, and you remember some of the general formula and some the short example which are we have to find the answer directly with this one. So thank you very much. Like, share, subscribe the video, and also share it to your friends which are studying in the same stream. So thank you.